All right, Math 189, section Zybook, section 1011, inclusion, exclusion, video 2. Right here, we're going to solve this problem. We're going to answer this question. How many strings of length 10 with symbols from A, B, C, D that have exactly 5 Ds or 3 Cs? Okay, so to do this, I'm going to define a couple sets. I'm going to say A1 is strings. Okay, now I'm going to not be entirely exact here. I should say strings of length 10 with symbols from there that have exactly 5 Ds. Strings, but I'm just going to say exactly 5 Ds. Say A2, oops, A2 strings exactly 3 Cs. Okay. And so try and understand how if we solve this, so really this question, instead of saying how many strings of length 10 with symbols from A, B, C, D that have exactly 5 Ds or exactly 3 Cs, if we understand that these are subsets of strings of length 10 with symbols from A, B, C, D, these are the ones that have exactly 5 Ds or 3 Cs, that we could ask this entire question just by saying so here, using this definition here of A1 and A2, I can say all this just by saying that. Okay. All right. Okay, so we know that by the inclusion-exclusion principle, the A1 union A2 is cardinality of A1 plus the cardinality of A2 minus the cardinality of A1 intersect A2. Okay, so remember that our length, I'm going to write this up, the length of our strings is 10, and our symbols are A, B, C, and D. Okay. All right, so first let's count A1. So I'll put this right here. Okay, let's count A1. We'll figure that out. Okay, so these are strings of length 10 where we have 4 symbols to choose from that have exactly 5 Ds. Okay, so remember how this goes. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got 10 positions. 10 positions. Okay, so we got 10 positions. We got we have to choose 5 of them to be Ds. Okay, so we'll choose. Let me just do there, 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 and there. Okay, so there's my 5 that I've chosen. Now, since they have exactly 5 Ds, that means that we only have 3 choices, A, B, or C, for the other positions, right? So we have 3 choices. 3 choices. 3 choices. 3 choices. So our answer here, so we have 10 positions. We're going to choose 5 of them to be Ds. Once we do that, we have 3 of the 5th choices. So we've got 10 positions, choose 5 to be Ds, and then whatever's left over, wherever those positions. Now think about this, right? If you were to move that D there, instead of choosing that position, you chose that one, then it would move the 3 right there, right? You have 3 choices there. It's the same idea. So we have 10 positions, choose 5 of them to be Ds, and then we have 1, 2, 3, 4, 5 times 3 to the 5th. Okay. So the cardinality of A1 found is 10 choose 5 times 3 to the 5th. Okay, so now we'll play the exact same game with the cardinality of A2. Cardinality of A2, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 positions. Exactly 3 of them are C's. Okay, so we choose 3 C's. 3 C's. Okay, let's put 1 there, and 1 there. Right, and then what do we have left over? We got 3 choices for each of these other places. So we got 3 choices, 3 choices, 3 choices, 3 choices, 3 choices, 3 choices, 3 choices. I'm just getting tired of writing choices every time, so I'm just going to write CH for choices, okay? All right, so again, our answer, let's see, we've got 10 positions. Choose 1, 2, 3 of them to be C's. And then we've got 1, 2, 3, 4, 5, 6, 7, 3 to the 7th. Okay. All right, so we're pretty close to the answer already. So the answer, let's see, cardinality of A1, we got 10 choose 5 times 3 to the 5th, plus here we've got 10 choose 3 times 3 to the 7th. And now we just got to figure out the cardinality of A1 intersect A2. So let's see. Oops, A2. Remember, this is the, let's just not have the cardinality for just a second here, right? This is the set of all strings of length 10. Strings, length 10, symbols A, B, C, D, such that 5 D's and, right, so if they're going to be in both of them, it's going to be in A1 and in A2. A1 is all the ones with 5 D's. A2 is all the one with 3 C's, so it's got to have 5 D's and 3 C's. Okay, so we're going to find the cardinality of this thing. Okay. All right, this is probably where the reason why we use the colon often instead of the bar for such that. So we don't want to confuse you with this is cardinality, right? So the number of these things. Okay, so let's see. We've got strings of length 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 positions. 10 positions. Okay, we're going to choose 5 of them to be D's. So let's choose 5 of them. 1, 2, 3, 4, 5. Okay, oops. A1 intersects A2. All right, so first we have 10 positions. Choose 5 of them to be D's. These are the D's. Okay. Now once we do that, we have 1, 2, 3, 4, 5. Now we have 5 positions. Choose 3 of them to be C's. This is the C's. Okay, so let's choose 2 of those to be C's. Let's say those there. Okay, then and remember this is exactly, right? I said exactly 5 D's and exactly 3 C's. So there's no ambiguity there. I'll write that in. Exactly. Oh, did I write in my 3 C's? I did 1, 2, oh. Okay, there's another one. There's 3 C's there. So we had 10 positions, choose 5 of them to be D's. Once we did that, those positions were taken up. Whatever way we did that in, there's many possible ways, right? There's 10 choose 5 different ways that we could have done that. Right, but whichever way of those we chose, then there was 5 positions left over to choose for the 3 C's, right? Okay, so then now we have 2 choices, right? Because with D and C, now we just have A and B. We have 2 choices, 2 choices. Okay, so times 2 squared. Okay. All right, so we're going to subtract that off. We got 10 choose 5. 5 choose 3 times 2 squared. Okay, that's the answer. I mean, you could figure out that number if you wanted to, but this is a perfectly good answer for this class. This is perfectly good. So that's the answer. Yay! All right. See you in the next video.